Right, so hello everyone. I'm going to introduce myself in a minute, but first let me introduce what I want to talk about today. So on this amazing picture, you can see the giant planet Jupiter. Jupiter is the largest planet in the solar system. You can see it in the background. And this big storm that you see is already a couple of times larger than the Earth, just to give you an idea of how large Jupiter really is. But this talk is not about Jupiter, it's about what you see in front of Jupiter. There's a moon of Jupiter here, it's called Europa, and that's also the moon that I study as a scientist. And Europa is a very interesting moon, I'm going to tell you why. It's not interesting so much because of what's on the outside. Europa is made out of ice, so that's why it's sort of white on the outside. What makes Europa really interesting is what's under the ice of Europa. Under the ice, there's an ocean of liquid water, and that covers the whole moon. And that ocean might be really deep. We think it could be up to 100-kilometer deep. And if that is really true, then that would mean that there's more water inside Europa than there is on the surface of the Earth. That's what this picture tries to show. So the blue balls next to every object is the volume of water in each of them. And as you can see, there's more water in the ball of Europa than there is on the ball that represents all the water of the oceans of the Earth. So really a lot of water, liquid water. And liquid water, that's very interesting because we know that liquid water is one of the things that is necessary for life. So maybe there is life inside of this ocean of Europa, this underground ocean. We don't know for sure if there is life. So we want to figure out if the conditions in this ocean are right for life. We want to know if the ocean of Europa is a good place for life. And how do we do that? How do we figure out if the underground ocean of Europa is a good place for life? We need three things for that. We're sending a spacecraft there, and the spacecraft has scientific instruments on board, and there are hundreds of scientists on the Earth working with the spacecraft and the instruments. So in this presentation, I want to answer three questions. Why do we actually need a spacecraft to go there? What are the instruments for? Why do we need them? And why do we need so many scientists to figure out something about conditions for life in the ocean of Europa? But before I go into the topic, I promised that I would say a little bit about myself. So I'm Hans, I'm from Belgium originally. I'm a scientist, space scientist. And already when I was a kid, already when I was in high school, this is where I went to high school, I was really interested in space and astronomy, and I joined an astronomy club. That's where I learned how to use a telescope. This is me when I was a bit older already, and I was teaching the kids of the astronomy club how to build rockets. You can see that everybody is holding their own rocket. And so because I was always really interested in space, I wanted to have a job related to space. And so I went to the Netherlands and I went to study aerospace engineering. In aerospace engineering, you learn how to design a spacecraft, like how to design a spacecraft that goes to Jupiter. But while studying that, I realized I didn't just want to design spacecraft, I didn't want to be the one that's just designing the spacecraft, but I also want to be the person that's using the spacecraft when we get to Jupiter to study Jupiter and the moons of Jupiter. And so I realized I wanted to be a bit more of a scientist than an engineer. So I moved to Sweden, to the north of Sweden, and there was a research institute there that built scientific instruments for space missions that go to other planets. And that's where I really learned how you study other planets. And that's where I decided, okay, I want to do science really, rather than just designing spacecraft. And to become a scientist, you have to take an important step in your education, and that's called a PhD. And a PhD or doctorate is an education where for a couple of years, you practice the skills of a scientist. And I did that in Germany at another institute that works with space missions. And now I'm back in the Netherlands and I work at the European Space Agency. So this is a very large laboratory, And we do all kinds of things related to the space missions of the European Space Agency. There are people from all over Europe working here, including people from Greece. So that was what I wanted to say about myself and what I'm doing. And now back to the topic. So why do we need a spacecraft? So I have a question for you just to check if you're still alive. And my question for you is, who of you thinks that we need a spacecraft to figure out if the conditions are in this moon are right to have life? So who of you thinks that we need a spacecraft to figure that out? Maybe you can turn on your camera and raise your hand so that I know if you agree that we need a spacecraft, just to see what you think. So, okay, yeah, I see one person, and the rest is maybe still a little shy. Okay. Hello? So, well, if there's only one person that agrees with me, then I can still try to convince all of you. So I think we really need a spacecraft to go there, to be able to study the moons of Jupiter.
Sorry, Hans.
Yeah.
There's a question in the chat.
Yeah, I didn't see that.
We agree that we need a spacecraft.
Aha. So there's
why, or the why, I think he's asking. Why do we need? Why do we need a spacecraft, or if we agree to have
yes. Let me clarify the question. So the question is, do you think we need a spacecraft to go there, or do you think we can do it from here? So if you agree that we need a spacecraft, just raise your hand or put a message in the chat. I'm just curious to see how many people agree. Okay. Thomas agrees. That's good. Okay, and Vasilis, right? So there's a couple of people agreeing. And the rest of you, I think I still have to convince. Aha, yes. Okay. Thanks for your input. Let's go to the answer. So I would say that we really need a spacecraft. And the big problem is that the moons of Jupiter are too far away from us to study them from here. You can look at these moons with a telescope. For example, this one here, this is a telescope in space. And it's one of the best that we have. And even with this telescope, if we take pictures of the moons of Jupiter, then those pictures don't look any better than the ones on the right. So here you see on the right 4 moons, Io, Europa, Callisto, and Ganymede. Those are the 4 biggest moons of Jupiter. And if we try to take pictures of these moons with the best telescope that we have, the one that you see here, then we still don't get any pictures that are better than the ones you see here. And these pictures are not really good. They're very grainy. The resolution is very poor. You can't really see anything on the surface of the moon. You can see a little bit of the color, and you can see where it's lighter and darker, but anything else you can't really tell. And that's just because these moons are just so far away from us. So if we want to be able to learn anything interesting about these moons, we really have to go there. So that's why we need a spacecraft, I would say. And I see there was one more comment. Yes. And so that's why at the European Space Agency, we're developing a new spacecraft that will go to Jupiter to study these moons. And it's called JUICE, the Jupiter Icy Moon Explorer. And this is what it looks like. And it's going to study Europa, I already mentioned that moon, but also Ganymede, another big moon of Jupiter, and Callisto. Those are the 3 moons that we will be focusing on. That was the first question. So the second question is, why do we need instruments? And I'm going to need your help in just a minute again, but let me first go a little further. So these are the 3 moons that I said that we want to study. And what do we want to figure out about these moons? Do they have oceans? And are those oceans good places to have life? For Europa, we already know that there is an ocean, we're pretty sure. But for Callisto and Ganymede, we don't know yet if they even have an ocean. And the ocean of Europa, even though we know that it's there, we don't know that much about it. We don't know for sure how deep it is. We don't know how salty it is. And we don't know how good of a place it is for life. So we need to learn more about it. Now, how do we do that? If, say, we get there with the spacecraft, how can we figure something out about the oceans of these moons? Because these oceans are inside, and it's way too difficult for us to land on a moon and make holes in the ice. We can't do that. So we have to study them from outside and learn something about their oceans. And that's very tricky. And we do that with scientific instruments. Those are measurement devices on the spacecraft that we can use to learn something about the moons. And the tricky thing is, there's nothing like a magical ocean instrument. There's not one magical device that we can take on our spacecraft and that tells us, yeah, there's an ocean, there's no ocean. There's no such thing as an ocean detector or ocean life detector. That doesn't exist. There's not one device that we can use to figure out right away if there's an ocean or not. So we have to bring a lot of instruments. Our spacecraft has more than 10. And all of these instruments we use to figure out something about the ocean. And it's when we combine the information of all the instruments that we can learn if there is an ocean or figure out if the ocean is right for life or not. This is probably a bit difficult to understand, so I'm going to explain in a little bit more detail how we can use instruments to figure out if there's an ocean. But I need your help again. I have a question for you. So, and the question is about imagining what kind of instruments we want to take on a spacecraft. What could be useful for us to figure out if there's an ocean? And that's a challenge for you, because I think that all of you have something near you right now that is a bit like the instruments that we use on the spacecraft. So I want you to think what that you probably have just next to you right now would be useful to put on a spacecraft. What device that you have near you can be used to make measurements like we do in a spacecraft. So I want you to think about that and tell me what that could be. You can show it on the camera or you can tell me in the chat as you wish. And if the question is not very clear, just tell me, I can explain it. Yes, somebody says a thermometer. That's a kind of scientific instrument that we can use. And I would say that there is something on the spacecraft that we can use to figure out the temperature of a moon. That's for sure true. Does anyone have any other device near them beside a thermometer? Something that you use every day, or at least I do. Yes? Yeah. I'm sure you know what it is. Some kind of thermal camera, yeah, maybe, yeah. Camera is going in the right direction, or in the direction of the answer that, yeah, your wavelength. An instrument that can penetrate the ice crust, yeah, you're already going very deep into the topic. Those are good ideas. I'm going to tell you what I was thinking. I think the instrument that you all have near you that, that I was thinking of is this one. It's a smartphone. A smartphone is a bit like a spacecraft. It has a lot of instruments in it, and that they are a lot like the instruments on a spacecraft. For example, the most obvious one what you already said, a camera. Smartphone has a camera. Spacecraft has cameras too, to look at the moons. But a smartphone also has other instruments that are like the ones on a spacecraft. There is a compass and a step counter. Those are all instruments that are in everyone's smartphone. And each of these three instruments are like the instruments that we use on a spacecraft to figure out if there is an ocean or not. So we need both the camera on the spacecraft, the compass, and the step counter. And with the information of each of these three, we can figure out if there are oceans or not. And I'm going to explain how that works. And I'm going to explain that by going back in time, because we discovered more than 20 years ago that Europa had an ocean. And that was done with the spacecraft that you see on the left. And one of the scientists that was very important in making this discovery is the lady that you see in the middle. She's called Margaret Kivelson. She's more than 90 years old. She's still alive. She's still doing science. And she's one of the most famous scientists in the world when it comes to the moons of Jupiter. I've met her myself. She's still working very hard every day on moons. And I'm going to tell you how she and other scientists figured out, using those three instruments, the compass, the step counter, and the camera, to figure out if there are oceans in Europa. Starting with the first instrument, the camera. So scientists took pictures of the moons of Jupiter. And here on the left, you see Europa, and on the right, Callisto. And you can see one very strong difference between the two. And yeah, well, maybe you can tell me what that is. What's the biggest difference that you see between left and right? I'm not talking about the size, because the size is not completely correct here. Something else that's very different between left and right. You can tell me or put it in the chat. Yeah, so just to be clear, the question is, what is the biggest difference that you see between those two moons when you compare left and right? The color of the surface, yeah, that's one. The marks and the lines, that's also an important difference. You're right about those. There is another one that's right now the most important one, and you haven't mentioned that one yet, but you're right about those differences. They're important too. There's something that the one on the right has a lot of, and the one on the left almost none. Yes, craters. That's good found. That's indeed what I was looking for. So the other ones were correct too, but for this story, the craters are most important. Callisto on the right is full of craters, like our own moon, and Europa has almost no craters. And that's a bit strange, because they're the same age. They were formed 4.5 billion years ago, and at that time, there was a lot of rocks in space. And these rocks were hitting all the new planets that were just forming, and they caused a lot of craters. That's why the moon has a lot of craters. That's why Callisto has a lot of craters, because in the beginning, when the solar system was formed, there was a lot of rocks flying around, and they would hit the moons and make holes in the surface. And that's the craters that we see. But how come Europa doesn't have any craters? That's a little weird. And scientists figured out why that could be the case. So these are two photos again, left Europa, right Callisto, but this time we zoomed in on the surface. And you can see that Callisto has a lot of craters, but Europa has none in this picture. Or at least you might think there are no craters in that picture, but actually there is one. If you look closely, on the left, you see these rings inside of each other. In the middle, approximately, all these rings, that's what a crater looks like on Europa. So scientists figured out that when a rock from space hits Europa, it makes a hole in the ice. And that hole is just like any other crater, but the hole disappears. And why does the hole disappear? Because when you make a hole in the ice, the water from underneath will fill the hole and make the hole disappear. So that's on the left why you don't see a hole in the crater. It's the hole in the middle is gone. And that's because it's filled up again by new water that comes up and makes the hole freeze again. So Europa makes its own craters disappear because there's an ocean under the surface. That's what scientists thought. But they can't be sure that it's liquid water under the ice. It could also be slushy. Slushy, I don't know if you know that, but it's a drink that you can get at the beach here. It's made of ice, but the ice can still move. You can drink it with the straw. And so it could also be that on Europa, there isn't liquid water under the ice, but also could also be slushy, because the slushy is not liquid water, but it's still movable, so it can still fill the holes of the craters. So by using the instrument, the camera, and looking at the surface, scientists can see, okay, there are no craters, and that tells scientists that under the surface there's either water or slushy, but they're not sure which of the two. So they need more information. That's why they're going to use other instruments as well. And the second one is the step counter. So I don't know if you've ever used the step counter on your smartphone. I do it sometimes when I go for a long walk. The smartphone tells me how many steps I've taken. And it's the step counter, it doesn't really know that I'm taking steps, but it feels when my body is changing, when the acceleration, when my body, every time I take a step, my body goes a little slower and a little faster, and the smartphone feels that. It feels that my motion is changing, and because of that, it knows you're making steps. And we can do something similar with a spacecraft. We can figure out when the motion of a spacecraft is changing. And that's really interesting, because you can use it to figure out what's inside of a moon or a planet. So imagine you have that spacecraft again, and it's flying by a moon. And the moon is big, it's heavy. That means it has a lot of gravity. And gravity is the force that keeps our feet on the ground. When you jump, it pulls you back to the surface. And the moons do the same. But so what you have to imagine is that when a spacecraft is flying by a moon, even at the very high altitude, it's still feeling a little bit of gravity from the moon. So when you're flying past the moon with a spacecraft, the moon is pulling on you, and it changes the motion of the spacecraft a little bit. And what's really interesting is that the change in motion is different based on what's inside of a moon. So a moon that is rocky on the inside, like this one here, has a different effect on the motion of the spacecraft than a moon that has a water layer on the inside. So by looking at the motion of the spacecraft, by using the step counter of the spacecraft, you can see if there is a change in the motion. And from that change in the motion, you can figure out if there is a water layer in the moon or if it's all rock. And so the scientists saw, okay, there must be a water layer in this moon. But again, they can't be sure if it's liquid water or something frozen like slushy. So we need another instrument to be sure that it's liquid water. And that's the compass. So a compass in a smartphone is not really a compass. There's not a spinning. Is it density that affects the gravitational pull? Yes. So it, if you, let me try to answer that question first. So if you have a heavy layer in, like if you have a heavy material on the outside of the moon, the heavy stuff is closer to the spacecraft and has more gravitational effect. But if instead the heavy stuff is near the middle of the moon, it's further away from the spacecraft and will have a different effect just because it's further away. It's a bit of an oversimplified explanation, but it has something to do with the density of the different layers and how far away the layers are from the spacecraft in the simplest form. So I hope that answers your question. Going back to the compass, so your smartphone has an instrument on the inside that measures the magnetic field of the Earth. So you might have heard of magnetic fields. Maybe you've ever done this experiment with a magnet. If you take a magnet and you put little pieces of iron around it, the pieces of iron show you the invisible magnetic field of a magnet, and our Earth has its own internal magnet and also has this invisible magnetic field. And a smartphone has an instrument that can be used to measure this magnetic field. And a spacecraft also has such an instrument on board. And this Galileo the spacecraft that I've been talking about, it measured that Jupiter has its own magnetic field, a very strong, very big magnetic field. But the lady that I mentioned before, the Professor Kivelson, she figured out that near Europa, you could also measure a little bit of a magnetic field. But that magnetic field that she measured around Europa was different from that from Jupiter. It was sort of following the magnetic field of Jupiter. So when the magnetic field of Jupiter changes a little bit with respect to Europa, the little magnetic field in Europa was also changing. So it didn't look like that magnetic field was coming from the middle of Europa, from Europa's internal magnet, but it was as if that magnetic field was constantly following the magnetic field of Jupiter and changing every time Jupiter's field changes a bit. And that's a bit technical, but she figured out that that can only be explained by having a layer of liquid water with salt inside of Europa. Liquid water with salt is electrically conductive, and it will react to this magnetic field of Jupiter, to these changes in that one, and that creates a new magnetic field around Europa. So by using the magnetometer on the smartphone or on the spacecraft, they measured a little magnetic field near Europa, and that field tells us that inside of Europa there must be liquid water with salt in it. And so that's how she and her team managed to confirm that Europa has an ocean. So in the end, they figured out that Europa has an ocean using at least 3 instruments. The camera, which shows you there are no craters, but it doesn't tell you for sure that it's liquid water. The step counter also tells you there's a water layer, but again, not sure if it's frozen or liquid. And finally, the magnetometer, or the compass, so to say, that one you also use. And if you put everything together, then you know quite sure that there is an ocean inside of the moon. And on our spacecraft, we will also be taking a lot of instruments, just because, as I told you before, there is no magical instrument that tells you everything about an ocean. So you need a lot of them. And we will also be taking a camera, a magnetic field instrument, and a step counter, and many others. And that brings me to the last question. Why do we need so many scientists? So I said that there are 100 scientists, more than 100 scientists working with our new space mission. Why do we need so many? That's because we have many instruments. Oh, sorry. I was going to tell this in a different way. So why do we need so many scientists? So I'm going to explain it with an example from Star Trek. It's a TV series. I don't know if you've ever seen it, but in this science fiction series, people use a spaceship and they travel to other planets, and they go on adventures on these new planets. And one thing that always happens in Star Trek is that when they arrive at a new planet, there's like some genius that clicks on a few buttons and he gets measurements. And within 1 minute, that genius knows everything there is to know about a planet. That's really not how it works in reality. And there's more than one reason. So we have a lot of instruments in our spacecraft, and there is nobody smart enough to understand all of these instruments. Actually, there's nobody smart enough to understand even one instrument. It's so complicated that for every instrument, you need a team of at least 10 people to be able to understand what's going on, what you're measuring, what you're looking at. So because it's so complicated, because nobody can do it all on their own, you need a lot of scientists. And I mentioned only one scientist in this talk, that was Margaret Kivelson, who was very important when it comes to discovering Europa's ocean. And it was not just her doing it, it was she and her team of, let's say, around 10 people that were working with the magnetic field data. And then the teams of the other instruments, also at least 10 people each. So you need a lot of people, just because it's all so complicated and nobody can do it on their own. Every scientist brings a piece to the puzzle. And when you bring all those puzzle pieces together, you can really learn something about planets. And That's why Star Trek is not realistic. Not one person can ever do that themselves, like figure out everything about a new planet that you just discovered. That's not how it works. So that brings me to the summary. So what do we need to study other planets? We need a spacecraft to go there. We need a lot of scientific instruments, and we need a lot of scientists. And that's how we study other planets. And if you have any more questions about this topic, I'm happy to answer them now.